All right, guys. Good morning or afternoon, depending on when it is that you're watching this. Plan for today is relatively simple. All I want to do is make sure that you guys have the opportunity to finish up the rest of that worksheet that I had sent you guys. So yesterday, you remember, I really only had you working on the first three problems. All I'm going to do is just kind of go through those three problems to kind of remind you guys of what it is that we talked about and how we construct these based on what the parent graphs should look like. So we'll go through these three together just to kind of um, replicate it and stuff like that. Um, but then I'll have you guys finishing up the worksheet, and then that'll allow us tomorrow to kind of start sort of the review. And we were going to get to the point where I'm going to have you take some sort or some version of a quiz on this stuff relatively soon. Okay, once we start putting sine, cosine, tangent, cotangent, and secant and cosecant back together. So number one, the function we were supposed to graph was y equals 2 times the secant of 2 theta plus pi over 4. And we're going to kind of go right down the line the way that the directions ask us to. And I know that over the course of the last couple of weeks here, these worksheets have been kind of maybe a little bit frustrating because they don't put things in the same order every time. What this one actually asked us to do was it said state the amplitude, the reflection, the period, the phase shift, and the vertical shift in that order. So we'll just kind of go in the order in which it asked us to do this stuff. It doesn't really matter as long as we remember kind of how we need to think about this or the progression that we need to think through. So the amplitude is obviously 2. That's going to stretch this graph up 2 units. The reflection, there is none. There is no vertical reflection because there's no negative coefficient out front. Okay, so the period is one thing we want to remember. Period is always an adjustment of 2 pi radians or pi, depending on what the trig function is. Tangent and cotangent is an adjustment to pi. Anything else, it's an adjustment to 2 pi. So in this case, it's 2 pi over our coefficient in front of theta, which is 2. So obviously those cancel, and it is pi. At this point, this is kind of the starting point for our thought process here. What this, again, as always, allows us to do is this, okay? Whatever this is allows us to mark our first 4 units along our x-axis. So those 4 units need to stretch to whatever the period length is. In this case, it's pi. Cut that in half, you get pi over 2. Cut that in half, you get pi over 4. So a pretty common thing that happens here is our tick marks, each one of our unit marks on our x-axis is 1/4 pi. So we just kind of count up and we sort of double this. So pi, 1/4, 2/4, 3/4 pi, 4/4 would give us 1 pi. Then we get 5/4, 6/4 simplified is 3/2, 7/4, and then obviously 8/4 would give us 2 pi. So you can see that right there. All that the period length allows us to do, and if we want to, we could come back here and label kind of -1 and -2. This would be negative pi over 4, negative pi over 2. No guarantee one way or the other whether we'll actually need that or not, but we can do it, okay? All right, now here's 1, here's 2, here's -1, here's -2. I'm going to make each one of my marks on here, each one of my lines on my paper 1 unit. So here's 1, here's 2. Okay, we'll talk about the rest of this in a second, but phase shift. Phase shift is when you take this constant on the inside, you take its opposite, so negative pi over 4, and you divide that by whatever the leaf coefficient is. So divided by 2, this becomes multiplied by the reciprocal, so negative pi over 4 times 1/2 is negative pi over 8. All right, so this one might have caused you just a little bit of troubles. Okay, I'll tell you about that in just a second. Actually, since this is something involving asymptotes, we can deal with it right away. Okay, so what I guess I want to point out right now is this. We need to start our thought process with where are the original asymptotes? And what we always say is this. The original asymptotes, depending on what this is secant. Secant is the reciprocal of cosine. Wherever cosine has a value of 0, that's where secant is going to have a vertical asymptote. So if you think about cosine, cosine is one that starts at 1, then it goes down to 0. So typically, right here at our first x coordinate is where we would have an asymptote. But we need to move that asymptote left pi over 8. If you think about this, each one of our markings is 1/4 pi, but we need to move it left 1/8 pi. So our normal asymptote that would typically occur here at our first unit is actually going to occur halfway between our first unit. So this is one of those instances where our key points are all going to occur in between markings, okay? So basically what we need to remember now is, again, this. The parent graph has asymptotes at +1, -1, so we need to move that back half a unit as well. So right here is in between essentially my -1 and -2, even though it's negative pi over 4 and positive pi over 4. Okay, so here's this asymptote. All right, and then what do we do directly in between those? So if we want to think in terms of just individual units, this is a half, this is -1.5. Directly in between that would be -1/2. This is where, and I should mention here, I should finish this off, there is no vertical shift here because there was no constant at the end. What we always do in between these then is we usually will go up 1 unit and put a parabola there. Well, the vertical stretch or the amplitude here means that we actually have to stretch that up 2 units. So instead of my parabola starting right here, it's going to start all the way up here at 2 units. It's going to be 2 units above the x-axis instead of a single unit. And then all we have to do to finish our period is kind of do the next part of this, okay? So 1 unit to the right of this asymptote. So I'm 1 unit to the right. I'm going to go down 2 units and draw my parabola. And then another unit over, I'm going to draw my next asymptote. So here's my next vertical asymptote. And then basically we would just have to replicate that a second time for a second period. So again, right in here, 1 more unit over is where my parabola is going to go. 1 more unit to the right from there is where my next asymptote goes. 1 more unit from there is where my other parabola goes, down here at -2. And then 1 more unit to the right is where my next asymptote will go. There's 2 periods of this secant curve. And again, it all boils down to just kind of remembering that we're not too terribly worried about, what these scale is down here. The scale is really irrelevant. The scale is just set up when we find the length of our period. Once we get it scaled in, we just need to think about our x's as being 1, 2, 3, 4, 5, -1, -2, stuff like that. And I'll hopefully reiterate that and explain that even in greater detail as we go through number 2 and number 3. Okay, so number 2 was another secant problem. Actually, I'm realizing now these were all, I should have had you guys do like the evens or the odds yesterday, because I didn't realize that the first 3 were all secant problems. That's okay. So it's y equals 1/4 secant pi theta over 2. So pi over 2 theta plus pi over 2. All right, and again, no vertical shift here at the end. So we can kind of just go right down the line. Our amplitude is 1/4. There is no reflection, so I'll just say reflection none. The period is 2 pi divided by whatever this coefficient is. Now this is going to look a little confusing, but it's actually going to make our labeling really nice for once. It's 2 pi over 2. So if we again do reciprocals, it's 2 pi times 2 over pi. So the pi's actually cancel, and my period length is just in terms of actual regular numbers. It's just 4. So again, what the period allows us to do is just simply hold on one second. I gotta think about something here. Okay, good. I thought I messed up on that first one, but I didn't. All right. Anyways, here's 1. Obviously, this would be 2, -1, -2. Again, whatever the period does, it just allows us to label our first 4 tick marks. Well, in this case, just like up here, our 4th tick mark had to get us pi. Here, our 4th tick mark has to get us to 4. So literally, this is where we can actually just simply label our units by integers. 1, 2, 3, 4, 5, 6, 7, 8, and then obviously the same thing in the negative direction. So this is actually really nice. even though it's kind of irrelevant anyways, because once you get your x-axis labeled, you think in terms of integers anyways, right? We say that the secant usually has its asymptotes at 1 and -1. So here, that's exactly what we can think about because that's exactly what our labels are. We'll get to there because we have to see if there's a phase shift or a vertical shift. Here, there is a phase shift. It's the opposite of pi over 2, so negative pi over 2 divided by pi over 2, which again, negative pi over 2 over pi over 2, anything over itself is just 1. It's -1. So think about this. For the secant parent graph, the asymptotes are usually at 1 and -1, but now we need to shift everything back 1. So my asymptotes are now going to be at 0 and -2 for my first ones, right? Usually my first set of asymptotes are at +1, -1 for the parent graph. Now they've shifted back a unit, so 0 and -2. In here, in this space at -1 is where I'm going to put my first point. And again, since there is no vertical shift, I don't need to slide my midline up. The only thing I need to do is instead of putting my parabola up one whole unit, it's got an amplitude of 1/4. So it only goes up 1/4 of a unit. Okay? So it's going to go up 1/4 of a unit. I'm going to draw my upwards parabola. And then likewise, 2 more units here will be my next asymptote. In between there at 1, go down 1/4 of a unit and draw your parabola. And then just recreate that again. So again, this is actually really nice because our labeling is so simple. It's just by integers. So my next asymptote's at 4. At 3, that's my next parabola. And then next asymptote would be at 6. Next parabola would be at 5. Okay? So it's real simple. It actually works very similar to the way that most of the rest of these functions work. It's not too terribly difficult. Okay, we're going to look at number 3, and then we're going to call that good enough. The only thing that you'll notice about 4, 5, and 6 is they're all cosecant, which basically cosecant's a little bit easier because in the parent graph of cosecant, the asymptotes are at 0, and then 2, and then 4. Okay, so instead of being at +1, -1, and 3 for your parent graph, it's 0, 2, and 4 for your parent graph. So it's even a little bit, like I said, even a little bit easier on those. All right, anyways, let's finish this off. Number 3 is also secant, so we go y equals -2 secant, and then it's 4 theta plus 2. So this one looks a little bit weird because there's no parentheses, but all that means is there's no phase shift. All right, so amplitude is 2. The reflection is, we would say yes, or we could say it's an x-axis reflection because it's a -2. We'll talk about that in a second. The length of the period is 2 pi divided by, in this case, the 4. So here we are going to get some goofy stuff because the period length is only pi over 2. So let's talk about all the stuff we got going on here. All right, so my first 4 increments get me to pi over 2 radian. Cut that in half, you get pi over 4. Cut pi over 4 in half, you get pi over 8. So when I label my x-axis to have an accurate graph, I have to go up by 1/8 pi over every increment, okay? So 1/8, 2/8, 3/8, 4/8 is a half, then it's 5/8, 6/8 would be 3/4, 7/8, and then 8/8 would be obviously 1. I'm going to label just a couple back this way, negative pi over 8, negative pi over 4. Okay, but now again, once our x-axis is labeled, now we can think in terms of the secant graph usually has its asymptotes at 1, -1, and 3 for the parent graph, okay, where the first parabola is in between -1 and 1, so at 0, okay? Let's talk phase shift and vertical shift here. This time, there is no phase shift. A phase shift only occurs when there are parentheses, but there is a vertical shift of 2. So there's a couple weird things that are going to happen here, you guys, okay? For one, my x-axis effectively, or my midline, is going to shift up 2 units. So I am going to draw this imaginary horizontal line in there. Okay, the nice thing is my phase shift, there isn't one. So my asymptotes occur where they usually do, at -1. There's -1, at +1, and at +3. So in between these asymptotes is where my first period of my graph is going to take place. But we need to keep in mind, this is my midline. So think about this. For the secant and the cosecant, usually what we do to get our first parabola is from our midline, we go up 1. And then we draw a parabola concave up. This time, what we're actually going to do for this one is, since it does have a -2, we are going to reflect this. Okay, we're going to reflect it. Instead of going up 1, we're going to go down 2 from our midline, which puts us all the way down here at the origin. And then from the origin, we're going to draw an inverted parabola because we're reflecting the first one. The first graph is usually an upwards or a concave up parabola. This time it's a concave down parabola. Okay, and then think about your next one. My second one is usually down 1 unit. Okay, down 1 unit from the actual midline. I need to reflect that and stretch it up 2. So now I got to go up 2 units and draw a parabola. So I know this is kind of bleeding up there quite a ways, but that's what this one needs to look like. And then all I need to do is replicate that 2 more times. So here's another asymptote, and then I need to redraw this one. So from the x-axis facing down, 2 more gives me 1 more asymptote, and then I got to go 2 units above the midline and draw my final parabola, and I'm going to kind of just truncate it or squeeze it in there. Okay? So again, what you're noticing at this point probably is that all these graphs and constructing all these graphs really just is about getting comfortable and remembering what the parent graph looks like. This is why I've had you guys the last 2 weeks here actually copying the parent graphs into your notes to hopefully get familiar with them, okay? So that's as far as I want to take it today. I mean, hopefully that gets you there. Just remember, all you need to do for tomorrow is 4, 5, and 6. Turn all 6 of them. So these 3, make sure you have these 3 done, 4, 5, and 6 done, and just turn in that entire assignment. You can just submit it on yesterday's assignment because that was labeled. If you notice the due date, the due date is tomorrow, October 15th. So submit that, and then what that'll allow us to do is, starting tomorrow, we're going to put all this stuff together and we're going to look at some review sheets. So in all likelihood, you're going to have 6 problems to do, but each one of them is going to be a different curve: sine, cosine, tangent, cotangent, and then secant, cosecant. And hopefully over maybe like 2 days here, we can familiarize ourselves enough with these parent graphs to where we can replicate this on an actual quiz. All right, so if questions come up, let me know what they are. I can either shoot another video or just send back an email, but let me know what your questions are. Please make sure you're keeping up on this stuff, because we are going to end up, now that our virtual has been extended through next week, we are going to end up taking a quiz virtually. So I'll explain that a little bit more once it gets a little bit closer, but just keep up on all the work, you guys, okay? All right, finish this up and send it to me so I can get you guys some points for it. Have a good day. We'll talk to you later.